Hi guys, this what you see is a 1.5 HP 4000 RPM permanent magnet DC motor. It is very heavy with this flywheel. So guys, today in this video I'm going to test its regenerative braking. This is a 180 volts 1500 watts DC motor speed controller, low high. Let's connect it to this motor. Everything is well connected. All I have to do is turn on the switch. Now guys, here as you can see, I have stripped the wires a little on both red and black. So I'm going to connect the load terminals and the multimeter terminals to this wire, so that when I disconnect it from this motor controller, I don't have to connect the appliance after disconnection, because it is going to be very dangerous. Now guys, to make sure that the meter has been electrically connected properly here and there to this motor, let's turn it on, pointing it towards 20 volts DC mode, and I'm going to run this inertia disc to see if this display indicates some voltage. You see, voltage is being displayed. So yeah, it's electrically connected. Now guys, let's connect it to the converter and turn the setup on. So guys, as you can see that it has been connected. All I have to do is switch it on and then remove the wires of this motor from the converter, and then see how much voltage is being displayed on the multimeter screen, and that voltage will be the braking generation. Okay, first pointing it towards 1000 volts. Okay, go. 76 volts, increasing the voltage. 100 volts more. 130 volts, high speed, a little more. As you can see that it is flashing 180 volts almost. Now let's disconnect the terminals from the converter and see how the voltage falls. The disc, inertia disc, has been charged completely. You can see the disc has been charged, wires have been disconnected, and the voltage is slowly and slowly decreasing to zero, but it is still charged. Very dangerous. Still running. Now let's force stop the disc. And zero. Now guys, here I have not connected the black wire to this blue wire of this 100 watts incandescent bulb that we use in our houses. So anyways, let's charge this inertia disc of this motor. Okay, turning it on now. Let's increase the speed a little bit. At present, I'm working with this setup at 50% power mode. Now let's disconnect the wires and touch this blue wire of this bulb, left out wire, to the black. And let's hope that this bulb glows. Okay. Wire disconnected. You see the bulb is glowing 100 watts. Slowly the illuminance is decreasing, of course. Let's brake stop it. Stop. Now guys, let's try this 500 watts energy wasting halogen. Okay. Let's start. Increasing the speed. %75% of power being fed to this motor. Like the wind pressure is towards this side. Let's turn it off. Okay. Whoa. Wow. That was really bright. You can imagine how much energy was stored in the inertia disk. And guys, now comes the 1.5 kilowatt halogen. 1500 watts. I've never seen such a halogen. And guys, size of a 500 watts halogen is this, and this is 1500. You see, it's 3 times the size of this. So guys, now this motor is going to be fully loaded during regenerative braking. Let's connect this. Okay. And finally this terminal, and it should glow. Connecting the motor terminals to the converter. Okay, one done. Second also done. Let's keep it a little apart. Yeah, this much is fine. Let's turn it on. There you go. Increasing the speed. 50%. 75%. 85% power. Now let's disconnect it. I have to be quick. Oh, let's hold it. Oh. Cool. So guys, actually the halogen was on the white chart paper, so its visibility was not that good. So I have placed it like this for you to see it better. Okay, so let's get started. And guys, this time I'm going to turn it off from here and not disconnect the wires. Okay, you have already got the point. So it's started. Let's increase the speed. 25%, 50, 75, 85%. Good enough. Turning it off. Let's connect this wire. Whoa. Cool. I connected this wire to the vise because it is electrically connected to this halogen. Let's give it one more try. Bringing it back to 0, turning it on. Whoa. Yeah, actually there was a lot of spark between the clip and the vise, so I think I should better place this directly to the other terminal of the halogen. 0. Started. Okay. Much brighter now. Oh, cool. I forgot to bring it down to 0 and I mistakenly turned it on. And guys, before finishing off the video, I also wanted to test if this regenerative braking energy is enough to start an angle grinder and run it. So let's check that out. Hey guys, I've connected the angle grinder. You can see these wires connected to this pin, which is the wire for the angle grinder here. Okay. Yeah, make sure that it is always turned off. Yeah, it is off. Okay. Yeah, this is the last one. I'm going to finish off the video after this. Connected. Yeah, everything safe and sound. Pointer at 0. Turning it on. Increasing the speed. Turning it off. Off. Oh, so powerful. Really good. That was really nice. It is slowly decreasing the speed. This, what you see, is a very powerful brushless DC motor that I salvaged from a Xerox machine or an old photocopy machine, and I did a few tests and I salvaged it and restored it into a good working condition motor by replacing the previous installed circuit. If you want to watch that video, link will be provided in the description below. Do check it out. Today in this video, I'm going to use this very generator to produce large amount of electricity. The best part is, guys, you see this head. This is the gearbox, the reducer gearbox, because of which the RPM is only 180. It can be used in low RPM applications in case of generators, okay, like wind turbines or hydroelectric generators, where the RPM is low, but you have large blades for the starting torque, and then it is going to generate huge amount of electricity. And the best part is that it has no brushes because of it being a brushless motor, long life, mounted on bearings, and still very healthy. So in this video, I'm going to conduct a few tests on voltage, current, both open and short circuit, and maximum power rating as well. The shaft size is 10 mm and it is quite long, so it is again very useful. So let's get started. So guys, this is a crank, the handle that I'm going to use to attach to the shaft of this motor for testing it. And the shaft size is almost 10 mm, which is quite nice. And also its length is like this, so it is not going to get in contact with the base. Yeah, now it should be ready to go. You see, smooth. Wow. The best part that I love about this motor is that it is so old and still it is so smooth. The bearings are so nicely made and high quality. It's really easy to turn it. Yes, it's not loaded, but that would not be the case for bearings. Okay, so let's do some measurements. Now guys, you see these three wires coming out from this generator. Okay, so these three represent the three phase. I am going to connect only two wires to this multimeter that you see, because it can measure only single phase voltage. Okay, so I'm going to choose these two. And let's point the multimeter towards AC voltage measurement mode, and this will be our single phase voltage. Okay, so 17 volts was the maximum AC voltage that I could produce on open circuit with this generator. So guys, now comes the part of measuring the short circuit current of this generator. But the open circuit was easily measurable with the help of two wires. But for short circuit current testing, I will need a three-phase AC to DC converter or bridge rectifier. And this time I'm going to utilize all the three wires. So guys, it's time to connect the three-phase wires. These what you see, this blue one and this red and this black, these three are the three-phase input, and these two thick wires that you see, red and black, these two are the high current DC output. So finally we have converted AC to DC. It's time to test it. Now these wires are not needed, and this meter can also measure DC current, which is the best part, with the help of this clamp. Okay, link will be in the description if you want to buy it. Pointing the meter towards 600 amps current mode. So to measure the short circuit current, you can see I've clamped the meter to one wire, but we will also have to short circuit these two terminals, the red and black, and then the current is going to flow and this meter is going to read it. So we are going to need another clip, and here we have another clip. Okay, and the wires have been short circuited. Okay, so this time the motor is going to be really loaded, so I will have to hold it strongly and then move it, and still it is going to be very difficult for me to turn the shaft. Okay, the amperes have increased to 1.48 amps. It's little tight, but not that much. I can easily reach around 2.5 amps, and it is very tight now. More force is needed. Around a 4.8 amps I have reached yet. 5.2. 6.96 amps, I think it was. Yeah, so 6.96 amperes was the max I could do with hand crank rotation, and I cannot continue doing that for long. Now let's move on to actual load testing. Let's start with this car headlamp bulb, and its rating is 100 watts. You see, 12 volts, 100 watts. Let's keep the meter aside. Yeah, got the second one too. Okay, so both the clips have been connected. You see that it has started glowing. Let's turn off the lights. Okay, I'm going to start turning it now. Bulb is glowing really bright. Once again. Wow. But yes, it was very difficult to turn it once it was loaded. Although guys, it is going to be much easier to blow this 35 watts bulb. Now guys, the connected bulb is only 35 watts, so this time it should be easy, not 100 watts. Let's see. Yeah, it is really easy. Oh wow. Very easy. Well, I can easily glow it to full potential without even standing. You see, let's turn off the lights and see this time. Okay. Simple turning and it starts. No power at all when compared to the previous bulb. The previous bulb was around 3 times more powerful than this one. Yeah, I can even fuse it. You see simple turning and it is glowing. Wow. So guys, when I was there outside searching for other stuff that I can glow with this generator, it just struck my mind that this generator produces three-phase AC. So what if I utilize just one single phase AC and step it up with the help of a 12 volts to 220 volts transformer, like a UPS transformer, and then power up 220 volts AC loads directly without any battery or any other conversion circuit. That would be interesting, right? So it seems like that I found one UPS transformer 12 to 220 volts. So let's connect it. As you can see that like this wire and this wire, these two are really thick, and these two are like red and green, very thin. So obviously these are high voltage low current, and these two are low voltage high current. So connecting any of the two wires from this generator, let's remove this one, and I'm going to choose these two and connect them to the low voltage side of the transformer. So guys, here what I have is a big 18 watts LED bulb. So I'm going to start with this one and then move on to the next higher load if I have it. With that being done, let's start the turning part. Oh, you saw such a simple turn and it started glowing. I didn't even think about that. Wow. Yeah, as soon as it starts glowing, this generator is getting loaded. But once it turns off, again, the load becomes very less. So let's give it a fast spin to see if it can glow continuously, okay? Oh, yeah, it is little tight now. 20 watts bulb. Yes, but it is working. Continuous output. Let's turn off the lights once again. It is turning out to be an interesting experiment. So guys, the lights are completely out. I cannot see anything. Well, I'm going to grab the handle. Yeah, got it. And that's the motor and that's the gear. Okay, yeah, I think I've got it. Let's turn. Whoa. Oh, wow. Isn't it so amazing? Oh, it's very bright. And it's not that hard. I'm sitting over here and then I'm rotating it and still it is glowing pretty bright. But as soon as I like reduce the RPM, it stops glowing. I have to keep it steady. Okay, yeah, but it works really well. Seriously guys, that was an interesting experiment. Oops, lights are gone once again. Let me turn on. Hey guys, look what I found. An induction motor fan. Well, I'm not sure if the single phase output of this generator is going to be enough to start it, but there's no harm in giving it a try. Let's see if it can spin it. So let's start with the turning part. Okay, keep watching that. No, nothing. You saw it started running. Once again. Oh, it is running very slowly, but yes, it is running. Let's move it fast. Yeah, this generator was able to start this one, but yeah, obviously the output power of this generator is might not be enough because I'm only utilizing one phase out of three. Okay, so one phase, and after that transformer losses, and then again the worst induction motor losses. Did you know guys that in an induction motor 40% of the received power is lost as heat and the remaining 60% is the only power that is driving the fan or the load. Okay, so that is why I seriously don't like the squirrel cage induction motors. There are a lot of losses, and the torque is also not that good when compared to the slip rings. In any case, even if it is a slip ring induction motor, still it is going to have better torque than this one. Hey, look what I found. 200 watts Ferox LED panel. Yeah, the transformer output has been connected, you see here. Okay, to this LED panel. Let's start it and see if it can glow this. It is glowing. It's dim, but it is glowing, and now it is very bright. Let's turn off the lights once again. Oh, again. And here we have, you see, when I turn it very lightly, then it is glowing, not that bright. Okay, but let's turn it faster. You see, it is much brighter, very bright. Light, medium, okay, and bright. And it is very easy. You see, I'm sitting over here and turning it, and it is glowing pretty bright. Fire! Wow. Hi guys, today in this video I'm going to teach you how to make an electric generator from a 220 volts drill machine. Now this pulley that you see, I got it from Bangwoods. Link for this will be provided in the description. The bore size of the pulley is 8 mm, so I will need a shaft of 8 mm size. Here, as you can see, that I have connected the drill machine terminals to the clamp meter, and as you can see, when I run the shaft, it generates around 1 to 1.5 volts DC because of the presence of residual magnetism. Now let's connect this LED and test if it generates enough voltage and current to light it up. Okay, but as you can see that it is not lighting it up because the presence of magnetic field is very weak. So guys, as you saw that the setup worked pretty smooth. Now what I'm going to do is connect the multimeter in the DC mode, voltage measurement mode, and then I'm going to run the motor to run the drill machine and measure the generated voltage. As you saw guys, that it generated around 5.5 volts DC without any excitation, external excitation, with just residual magnetism. Now I'm connecting a 3 volts battery with a 12 volts bulb in series to check if it is going to excite enough to light up this bulb. The bulb did not light up at all because the internal resistance of the drill machine is very high as around 70 ohms, because of which the circulating current was very less. But if we compare the winding resistance of the washing machine motor with this drill machine motor, then you will see that the winding resistance of the washing machine motor is very low as around 6.6 ohms, means 10 times less. Therefore, the current flowing through the washing machine motor windings is going to be 10 times more with 3 volt cell. So for that reason, I'm going to use this 12 volts 5 ampere supply to excite the winding of the drill machine. So guys, I have turned on the 12 volt supply, and as you can see that it is glowing the bulb at full 12 volts potential. So let's connect this 12 volt supply in series with the drill machine and the 12 volts bulb. And after that you will see that the bulb is still not glowing even a little bit. No glowing filament at all. Let's measure the current with the help of a multimeter to see the current flowing through the bulb and the windings of the drill machine. The current flowing is only 0.18 amperes, very less. Bulb still did not glow, which means that I will have to increase the voltage of the supply further, excitation voltage. So I'm going to remove the 12 volt supply and replace it with the 32 volts DC supply. Let's connect it to 220 volts, and as you can see that the bulb is glowing, not at full brightness, but yeah, a little bit, around 4 or 5 volts. As you saw that the bulb completely turned off when I ran it. Let's try it by reversing the polarity. It's running slowly, but the brightness of the bulb has increased considerably. This means that it is indeed generating electricity. I am removing the rubber belt and trying it with hands because the rubber belt is going to get burned out. You can see when I turn the shaft of the drill machine, the bulb glows a little brighter than it was initially when connected in series with the 32 volt supply. So guys, here as you can see that this is a 220 volts drill machine which I'm going to use to run this angle grinder at high speed. And I have used the same setup as I did with the washing machine motor. I've connected this 3 volts lithium ion battery pack in series with the 12 volts bulb, and all of them are in series with the angle grinder. Now this setup is going to work much better because the power rating of the drill machine was only 300 to 350 watts, but that of the angle grinder is 850 watts, because of which the internal coil resistance of the angle grinder is going to be much lesser, so it is going to circulate huge current even with such a small battery. Okay.